Hello guys, welcome back to my YouTube channel. My name is Mike Matthew KE and this is my programming series. So over the course of this series we've been looking at variables, functions, operators, loops and so on and so forth. And we've just been looking at them overally. We've not really been going into detail of how you can use them per se. So today we're just going to be looking at an example of how you can use them in your programming. Okay, so we're just going to have a bit of a question that we'll tackle in programming, and this will at least help you see how to use them. And with that, I will also be looking at how to think logically as a programmer when you're using these tools that you've been given, this tool set that you've been given in your programming language. How can you utilize them in your code? So uh, we're going to dive right into it. And so what we're going to be looking at is this question, which is create a function that prints a Fibonacci sequence up to the nth term. Create a function that prints a Fibonacci sequence up to the nth term. So for those who don't know what a Fibonacci sequence is, it's basically so a sequence is just a series of numbers, numbers that move numbers that just follow one another with a specific pattern. So in this case, the Fibonacci sequence is just a series of numbers where each number is a sum of the last two numbers. Okay, each number is a sum of the last two numbers. So if you can look at it here, so as you can see here, we have an example of the Fibonacci sequence. So it always starts with 0 and 1. So when we start with 0 and 1, then we'll have 0 plus 1 equals 1. Okay, so we got our next number. Then 1 plus 1 equals 2. Then 1 plus 2 equals 3. Then 2 plus 3 equals 5, and so on and so forth. So it continues continuously. So now going back to our question, create a function that prints a Fibonacci sequence up to the nth term. So that means we want to limit how many numbers that we'll have in this sequence. Okay, so I'll just dive right into code here. And so the question again, if you look at it, it says create a function. So we'll have to do this in a functional manner. So I'll do it a couple of different ways. I'll start with C++, then we'll go to Python again, and I'll implement it a little bit differently. So all methods will work. It's just I'm just trying to jog your mind in terms of how you can be using these. So you can start with creating our function. So since we're printing, in this case, we won't need to return anything. So we'll have void, and then we can call our function Fibonacci. I'm not sure if it's supposed to be double C or double N. I'll look that up, and then we'll pass a constant integer that has our maximum count. Okay, so again, remember in your naming, as you're naming your variables, as you're naming your functions, always use names that make sense. Okay, the name should have meaning. Don't just have generic names. Okay, so you can see here we've named the function Fibonacci, and we've named our integer max count. That way it makes sense when you look at it as a programmer. And then we've made this constant, since this count value should not be changing within our program. Okay, now how we'll define this. So in this case, I'll just do it this way. So we're supposed to add the last two values, right? So I'll create one integer, the second last integer, which I'll call second last value, val for value. So when you're starting, the second last value is 0. So we always start with 0 and 1. So the second last value will be 0. And then I'll create another variable, which I'll call it the last value, which is 1, just as the sequence starts. Okay. Now, we need to go from these two values all the way up to the maximum count. Now, you remember in this case, we do not know what the max count is, right? So that's something that will just be passed by the user. So now we've already reached this is our second value, right? So if I do it this way, so how many values do we have currently? Let me call it current count. This is a variable, which is 2. We already have 2 values that we've already started with, right? So I'm just going to print out this. So if you remember in our last in our bonus episode for C++, we looked at stdcout, which helps us print, which I said we'll define better as we go along, because this involves classes which we've not looked at. However, we can just be using it. It will make things easier rather than using the printf value. So stdcout, and then we'll have our second last value, since we're supposed to print. So we want this to be a function that prints. This time, yeah, we'll have std endline as well. Okay, and then we'll also see out our last value, std endline. So don't worry if it looks too long. We're just trying to. In fact, let me just move these declarations down here, so that we can separate the declaration and the printing. And then we have our current count. I can also put it up there along with the rest. So next we'll look at how do we get the next values in the series. We already know that we only need to add the second last value and the last value, right? So the easiest way to go through that series is through using a loop. So our loop will start from the first 2 values, and it will move on forwards up to the maximum count. So how can we best represent this in code? We can do this using our for loop, and since we've already saved our current count, we can use our current count as our starting point, and then move on forward through the loop until we reach our max count. So if I start with I'll start with this. So remember, we if you remember, our template is usually int. A generic template will be something like this. We have our declaration, then we have our condition, I less than max count, and then we have our the final thing. We'll have our increment, right? So we'll do I++, and then we'll start condition. But in this case, since we've already declared this current count outside here, instead of having to declare it again, we'll just do current count like so. It's already declared, so you don't need to say it's an integer, and we've started at 2 instead of starting at 0, right? So again, here when we compare, we'll do current count, and then we'll move all the way up to max count. So I'll use this less than or equal to, and then here we'll have our condition, our increment, which will be the current count plus plus, which is saying just increment this current count by 1 on every loop. Okay. So now we are already at our second value. So so at this point, what do we do next? We need to get our next value. So the next value, I'll declare it in here. Next value is equals to this is supposed to be next. So our next value is supposed to be our second last value plus our last value, just as is in the definition of the Fibonacci sequence. Then from here we have now to update our second last value and our last value. So remember, we've gotten our next value. I'll just print out the next value here. We'll just see out the next value so that it's printed. Let's do the end line. So we'll just print out our next value here, and then we'll be looking at now that we've printed our next value. It means that in our series, if we're looking at what we've done so far, if we write it down, we have 0, 1, and 1. So from this we can see that now in our series the second last value is 1 and the last value is 1. So what has happened in this case? So when we had this and we introduced this, it means our second last value updated to our previous last value, right? If you think about it that way, we have this last value has now become our second last value, and then our next value, which we have already printed now, will now become our last value. In our logic then, we'll say the second last value will equal to the last value, and then our last value will equal our next value. Okay, so that's our logic. This way we'll be able to update our second last value and our last value every time in the loop before we increment our count and print the next value. Okay, so this is one way that we can implement this Fibonacci function. It should be able to do exactly what we need it to do. Now, something that you need to note, the order here matters. So in coding, we always do it from top to bottom. So execution will be top to bottom. So in our function here, whenever we enter the scope of the function, execution will be top to bottom, which means when we do this, we are updating second last value to the last value. If by any chance someone does, let me just separate these two. So if by any chance someone does it this way, updates the last value to the next value, and then updates the second last value to the last value, this will not work. Why? Because we've updated it to we've updated last value already to the next value, and then now we're saying the second last value is equal to the last value. So that means our second last value will always be equal to our last value as we continue through the loop, and that will make it incorrect. Okay, so that's something to consider as you're coding. The order of which you have put your logic matters. It really matters a lot. So I'll return this back to the way it should be, and then we'll do our function. So we'll run our function. So I hope you remember how to run the function, and then we'll say, let's say we go to the sixth term, right? We want our sixth value. So I'll here we have to have a semicolon. So if I run this, you can see that we've been printed for our first 6 values. So this is 1, 2, 3, 4, 5, 6. Oh, now we have 7 values, which is not the right thing, right? So as I hope you're thinking about what that means. I'll be looking at that shortly, but you can see now we have 0 then 1. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 5 is 8, and so on and so forth. So now back to the question, why is 6 printing, why is our max value 6, yet we're printing 7 values? What is wrong there? Now, if we come here, if we look at this correctly, we see that our condition says, while our current count is less than or equal to our max count, then you should execute this. Okay, so now let's run a scenario where let's say we want to go up to to the third value. Okay, so if I run this, what we'll get is 0, 1, 1, and 2. Of course, now let's look at this in execution. Okay, so we'll just think about how our logic is working in this for loop. So if we start here, at this point our current count is 2, so we'll just print let's do our first iteration. So when we're doing our first iteration here, we have our current count as 2. Current count as 2. Of course, it has not changed because when we enter the loop, it does not increment fast. It will remain as 2. And then we have our next value will be second last plus last val, which will be 1, right? Okay, then when we come here, of course we do our update. So we have, let me just print it at the bottom of the two of them. So we have second last value. So I have our second last value here will be updated to 1, right? And then our last value here will be updated to 1 because that's what our next value is. Now, when you come to a second iteration, remember our current count has been added. So that means current count will be updated to 3. And then our next val will now be 1 plus 1, which is equals to 2. So that means our second last val will be updated to the last val. Remember our last val was 1, so we'll have last val here as 1. And then, sorry, this is second last val. And then again, our last val here will be 2, because that's what we've denoted as our next val. Okay. Now, when we continue with this, you remember we have said we are running through this condition here. So we are asking ourselves what if you're looking at our max count, we are saying 3. So as this is evaluating, the first time when we run it, we'll have current count is 2 originally. So definitely is not, it's less than or equal to 3. So it will continue this iteration so that we get our 3 printed out, our first next val being printed out. Then when we go to our next iteration, we are looking whether 3, which is our current count, whether 3 is less than or equal to the max count, which is 3, and that is of course true. So that means it will go through this iteration, okay, and it will print this. But now, if you look at our general sequence, what we have printed out so far, we've gone 0, then 1, then 1, then 2. If you're looking at our sequence so far, originally we started 0, 1, 1. So at this point, it was 0, 1, 1. Then on our first iteration, it became 0, 1. At the first, we had 0, 1. Then second, we have 0, 1, 1. And then the third time, now we have 0, 1, 1, 2. But then these are 4 values, not 3 values. Okay, so in this case, now if you want to fix our logic, then that means we need to remove this equal sign. Why? We need only our current count maximum to reach the value 3. So you see our current count, it tells us where we are at exactly. Basically which count of value, which number in the series have we printed last. Okay, so when we enter here, our current count, if we look at it logically, is 2, right? So then we are at 2. Next, when we come here, we get our next value, and now we have this. If I can print, let me put this up here. So we have this because we've gotten our next value and we've printed it out. Now we have this. So that means we need to increment our current count. So that will be done by our for loop later on. But anytime this current count reaches 3, that means we've reached the end. Which means when our current count is 3, we should not execute this for loop. That's why this equal less than or equal to will be incorrect, because when we reach the count of 3, we've reached our third value. That means when we've reached our third value, we should not execute this loop again. So our current count, whenever it's 3 or greater than 3, should not execute, and that is why we do not have this equal sign here. We'll only look at it current count less than the max count. I really hope that makes sense. It's something that can get easily confusing. It's kind of the same way when we do when you have an array and we start from index 0, and then when you do this condition, it will still be less than the maximum size of the array if you're looping through the entire array. It's kind of the same way that it works. So this is something that easily confuses people in the beginning stages when it comes to loops. So that is something that should also be checking into. Right. So now if we do it this way, then we won't have this iteration here. This second iteration, we'll only have one iteration, and our result will have only 3 values being printed out, and that is exactly what we need. So now if I run this again, we'll have 0, 1, and 1, which is our 3 values. If I return it to 6 like we had originally, then we'll have 0, 1, 2, 3 up to 5, which is 6 values, right? So that's one way that you can do your Fibonacci sequence. Okay. Now let's try to look at this in Python. So in Python, first of all, we're just going to look at something new here that I've just written. So I'll just use the reference for. You can see here we have our main function, right? So in Python we have an equivalent of that, which is this. It's basically saying this will be our entry point. This is where we'll start our application from, right? So any code that we write within this if name equals main condition will be our starting point of our application. This is where we'll start our execution from. So it's basically the same as our main function here. Okay. So that is something new. We can look in depth into that, but it's basically just that. This is our entry point. This is where you're starting application from. So any code that is executed here will be our starting point. We'll look at that a bit deeper later on. However, for today, we'll just look at our Fibonacci function. So we'll define it the same way as we did Fibonacci, and then we'll have our count, our integer, which will be max count. So now this is another thing that I'll introduce in Python today. This is something called type hints. It basically works the same way as the way we do it here. Int max count, right? You can remember that in Python we do not have const, so we have this int max count. So max count, which we are saying is an integer, it's a type hint. It basically tells the program we are expecting an integer here. Okay, it's a suggestion to the program that we are expecting an integer here. And the good thing about using type hints is you as the programmer are in a position to know this is what I've been expecting. So if you've written code, let's say in January in the previous year, when you come back, and you can already know by default that you're expecting an integer. That's the downside of having it this way, is you have max count, yes, which if you think about it, because of the naming, it is obvious that it should be an integer. But what if you're using a different type of variable? Maybe you have a more complex application that the variables don't make direct sense. Having these type hints will allow you to know this is supposed to be an integer. So from now on, we'll be using this type hints. So for the return type, we usually denote it this way. In this case, our function will not be returning anything, so we can just use none as our return value. It basically means we're not going to return any specific value. Okay. When you continue here, this time we'll be doing it differently. So we'll have our sequence written out in a list. Okay. So we'll create our list. We'll call it Fibonacci sequence. With type annotation, this will be a list of integers, and we'll initialize it with 0 and 1, okay, which are our initial values. Whatever we do, we already know that our initial values will always be 0 and 1. So luckily for us in Python, our lists are extendable. Basically, you can add values to that list. They are basically dynamic in nature. You can add values to the list, in contrast to the basic arrays that we have in C++, which require you to specify a specific size. Later we'll look at C++ how we can have dynamic lists. That's something that we'll look at later. However, for now, we'll be looking at it in Python. In Python, there's a function called append. So if we have our list here, we can say .append. Okay, .append basically means this is a function that applies to this list. Okay, so .append, just add something to this list. We'll be looking at something called objects later when we look at classes, which will define how this works better. Okay, so .append, and then we can put our value here. Okay, so for now, I'll just cut this out so that we can go back to our logic. So again, we'll start with the way we did it before. So we have our current count, which is the length of our list, Fibonacci sequence. Okay. So again, whenever you're coding, it's usually best to avoid something that we call hard coding. Okay, it's usually best to avoid hard coding. So for example, in this case, hard coding will be to say that the size is 2. So what happens if I had defined 0, 1, 1 and I define the I meant like this way, and I define the current count to be 2, then that means I'll be definitely saying something that is not correct, right? So to avoid hard coding, we can just get the length directly rather than stating it out of the blues. Okay. Then we'll do our for loop like we did in Python. In C++. However, in this case, we'll just do for current count in range. So we already know our maximum is given, our max count, but we also need to remember here that we are starting from 2. Remember this function, the range function, will by default will print 0, 1, 2, 3 up to our max count. So if our max count, for example, is 4, then if our max count is 4, then we'll expect this to go from 0, 1, 2 up to 3. 4 will not be included. Okay. So in the case where our current count does not start from 0, we'll include it as an initial parameter. So we want the range to go from current count up to the max count. So what we'll do in this case, we'll just append everything to our sequence. So we append. So what are we appending here? We will be appending the second last value and the last value. Luckily for us in Python, we have a way of doing that, which is -2, plus Fibonacci sequence -1, basically saying our second last value and our last value, right? Then at the end of this function now, after we've appended everything to this sequence, to this list, basically, we can print the entire list, of which you can do it with for I or for index, using the right naming conventions, basically using names that make sense. So here, instead of using max count, I'll use the length of our Fibonacci sequence. This is basically so that we can also be able to know, in case we've not written our for loop correctly, right? At least we'll know we'll be looking at the exact size of the actual Fibonacci sequence. So in case, let's say, we made an error here and our Fibonacci sequence has 7 values instead of 6, for example, then if we use len, then we'll be looking at the actual size of the Fibonacci sequence. But if you use the max count, then we'll be basically making sure that we've printed the right thing, even though the list that we've created is not what is actually being depicted. So I hope that makes sense. We're basically using this so that we can be able to show the right values. So then we can print the value of our Fibonacci sequence, which will be Fibonacci sequence at index. So if I run this, sorry guys, forgot that we need to call the function, of course. So here we'll call our Fibonacci function within our entry point. So let's do Fibonacci up to 6. So if you run this, you can see 0, 1, 1, 2, 3, 5. So this is going up to the 6th term. So and you can see this is actually the actual way that it's supposed to be. So that means our function is working correctly. So you can see this is a simpler way of doing it. It definitely reduces the amount of code that you need to write compared to the way that you were doing it in originally. So you can still do this implementation in C++. Okay. Of course, there you'll have to consider the fact that you have arrays that cannot be dynamically expanded. That is something that I'm giving you as a challenge. Try and figure out how to do this this implementation of the Fibonacci sequence in C++. That way, you'll research a bit about how pointers work. You'll research a bit about how to dynamically extend your arrays before I can even get there, or even how to use those arrays as they are with that fixed functionality to be able to do it the same way as you've done it in Python. So I hope you guys have enjoyed today's lesson. I hope you've gotten to learn something. So the two implementations of the Fibonacci sequence that we've done. Of course, that is not the only two ways that you can do it. There are other ways that you can do it. It's really when you're doing programming, you just have a tool set that you can use in different ways. How you use it, how optimal your code is, that is up to your creativity as a programmer. So another challenge I'll give you, try and create a Fibonacci sequence in a different way from the way I've done it here. Try and look and see a way that you can do it. Maybe in the future I can show extra ways that we can look at how to do this Fibonacci sequence. Okay, so I hope you have enjoyed this lesson. I hope you have learned something, and we'll see you guys next time.